So good morning. I was just joking to Troy, I'm at the age now where I bring both my sets of spectacles up on the stage. So today we're going to discuss ontologies, and there's quite a lot of crossover with philosophy. So this session assumes a reasonable grounding in Aristotelian metaphysics. Nothing too challenging, just the sort of base level stuff you would have covered off in your early time at university. The holomorphic stuff, form and matter, maybe you would have read books, zeta, eta, theta, not necessarily in Greek, English translation's fine. You probably want some familiarity with Kant's critique of pure reason, the transcendental analytic, categories of understanding. Kant spent about 800 pages exploring how to impose categorical structure on experience in order to reason about it coherently. We're going to do something similar today, but shorter, with less German. Because we're going to be talking about systems that are built in Silicon Valley, you'll also need some understanding of the philosophy of Ayn Rand. Again, probably just to the level that you picked up in that time in your late teens. She called her philosophy objectivism, which is either an uncanny coincidence or the reason half this room got into software engineering. And then finally, Rawls. John Rawls, A Theory of Justice, specifically the veil of ignorance. His argument that we should design systems, just systems, without knowing our position in them. Your AI agents are already doing this. They have no idea where they sit in your organization or what anything means. Rawls considered this a virtue, and we're going to argue it's a problem. No, I'm just kidding. That was the cold open, ladies and gentlemen. We are going to talk about ontology, but we're not going to be all academic and sort of philosophical about it. We're not even really going to deep dive into things like Auld, RDF, Sparkle. Any ontology people here? Cool, I'm going to convince a whole lot of you. We tried this with the semantic web back in the early noughties. We'll talk a little bit about sort of why it's good to revisit it now. We're going to be talking about how we build a machine reasonable and understandable model of our organization. And that's something that's really going to light up the capability of our AI agents to actually operate across the context of that organization. These models integrate data, logic, business rules, so that the agents can reason over your organization. So my name's Chris Auld. I am a reasonably new to Sydney person, arrived August last year, and originally come from Auckland. You can probably tell from the accent. Spent a bunch of time in Singapore, 9 years in Singapore, working for Microsoft. Came to Sydney with the friends at CommBank. CommBank people, thank you for sponsoring this conference. And then Microsoft poached me back. Done a few things over the years, built and sold a company called Intergen that turned into Empired, OBS people, Empired people, awesome, ultimately became Capgemini. Built and sold some other stuff, so a recruiting company, a car parts company, we just sold that a couple of weeks ago actually. Hooray, and a multi-million dollars a year through the bookie AI automated gambling system. Not allowed to tell you exactly what we were gambling on, but Richard Campbell knows, and if you give him enough Starwood whiskey at the Baxter Inn tonight, you can probably get it out of them. I trained as a lawyer and a technologist, chose keyboards. We'll talk a little bit about the law today. And I did have an Ayn Rand phase. Who had an Ayn Rand phase? Am I the only? No, come on. Or were we just waking up this morning? No, everybody had an Ayn Rand phase. I've still got the books on my bookshelf. Air Canada. So a court ruled against them not because their agent lied, but because it didn't know what it was allowed to promise. Anybody familiar with this one? So a guy called Jake Moffat had a bereavement, jumped online in the chat bot. Air Canada said he could have a discount. Turns out he couldn't. So we took them to the civil tribunal in Canada. The failure here wasn't that the model lied or necessarily hallucinated, it's that it didn't actually have an understanding, a reasonable understanding of what it could commit to, what was an authorized commitment that it could make. And this isn't an anomaly. There are plenty of examples of this. And this is a risk, and it's a reason that many of the sort of the POCs that we've been building aren't actually getting to production. Who's done a POC that's not gone to production? Lots of people. Especially if you've got a risk team. I get stuck in risk purgatory. And the reason is simply, it's very easy for us as engineers to fool ourselves that we have something that works that then doesn't generalize once we put it in front of customers. And one of the reasons for that is the AI truly doesn't understand the intricacies of our organization. I'm going to propose to you today that building ontological models of our organization and our systems are going to help to solve for that. The industry's diagnosis is pretty simple. We need bigger and stronger models, and the models are amazing and get more amazing every month. Certainly even just the past 3 or 4 months, some massive uplifts. But the model's not necessarily the bottleneck. We can do better prompting, add rules, more context, more examples, sort of few shot learn a few more things. Prompt grows, still hard to capture those edge cases because we're trying to explicitly encode cases and edge cases rather than giving the model to the agent to be able to reason over. More tools, better RAG. Again, we have those tools, but ultimately it doesn't know how to retrieve the information that it actually needs to work with. So LLMs aren't necessarily failing to reason, we're failing to tell them what things mean so that they can then reason over that. So what is an ontology? And again, I'm not going to dive into syntax here. I've got a couple of sort of lightweight Keynote level demos. The most important thing here is to understand the meta-ontology, right? What is the model of ontologies? They are machine-readable and machine-reasonable models of the things in your domain, the relationships between them, the rules that govern those relationships. Again, you can go back and read some philosophy because it's fundamentally grounded in that. But at a high level, we need to model out our concepts. We're going to talk a little bit about a faked-up pharmaceutical example, patients, medications, diagnoses, indications, contraindications, right? Starting to get into edgy topics. Relationships, right? What are the relationships? Providers prescribe medications. Contraindications tell us what we can't take based on medications having problematic interactions. And what are some of those rules, right? Like a logical rule, a patient cannot receive a contraindicated medication. So it goes beyond merely a data model. And then an agreed vocabulary, because so much of what we're doing with these systems now is interacting directly with humans. They are co-pilots. I'm from Microsoft, I can say that word. I'm not going to talk about products much today, right? But we are empowering humans to try and help them to become more productive. And so that ability to speak in common nomenclature is really, really important. Who's seen the king minus man plus woman equals queen party trick, the embedding model party trick? A few people have seen it. If you haven't seen it, it's a really cool little trick that you can do with like word-to-vec embeddings. So you project the embeddings up into embedding space and you can actually perform algebra on them. I won't go into it. I'd assume probably I'd get a few more hands up here. But it's good fun to go and have a look at. But ask yourself, why does that work? Like, why can we do this algebra in embedding space? And it works because because basically the similarity between kings and queens and also the differences, gender, are projected up into semantic space. And that semantic space has been learnt by training it over human language. But the reason it works as a party trick is that it's not just that implied semantic model that's been learned, but there is actually a model in human understanding around what is royalty and what is gender. And so it's really important when we think about ontologies, we're working with ontologies that are not just machine understandable, we're working with ontologies that are human understandable as well. Because LLMs are learning implicit meaning, right? They're learning those relationships implicit in the training data, embedding that analogy at scale, right? The king-queen is just one example of a relationship that's embedded into the model. There are lots of different relationships embedded into the model, so not all analogy is created equal. There's all sorts of spurious relationships in there that we don't necessarily want to be able to rely on, so we may want to tighten the model down in terms of what it's actually going to work with. Right? We need a way to actually have a shared model, an explicit shared model. Right? Otherwise, much of that algebra is just noise. So the idea of building explicit ontologies for our systems is that they're going to give that agent's really rich, really sophisticated, more sophisticated by the month ability, something to reason over, something to anchor on. An understanding that's shared with our organisation's people, something that knows what a credit limit is. What's a credit limit? What's a credit limit? Come on, you guys are half asleep. I thought credit limits, the maximum number of credits I can take at university in my first year course. And if you'd answered the other way around, I would have flipped it, right? because the answer is it depends. And I think that's the important thing to understand is it depends, and so it depends is an awfully risky way to flight stuff into production. And we're going to talk about an example shortly with an Australian regulator. Australia runs a fantastic licence rage. Like, you've got to get a licence I've got a boat licence, I've got a driver's license, I've got a working with sheep certificate. Got to have a little bit of deprecating the Kiwi humour. So it's not just a data model, right? The data model says a customer has a credit limit, it's a decimal field stored in the customer's table, that's kind of it. Right? We can't really reason over that. We can reason over that, but we reason over that by relying on the implicitly encoded knowledge, right? That we may want to sort of put some stronger priors around. And that's really what the ontology lets us do. It lets us put some stronger priors on. It's a structured way of constraining the model, right? The ways that we tend to constrain the models, fine-tuning. We don't tend to bother fine-tuning anymore. Or few-shot learning, right? Ontologies are a great way to one-shot or few-shot sort of learn and constrain that model in a really structured way. Right, so a customer has a credit limit that can only be raised by a credit officer. Raises above certain thresholds require delegated approvals. If they're under a litigation hold, we freeze things. And then the agent basically inherits all of that knowledge by construction formally. So what might that look like, right? So we might have be sort of encoding our decision model into that ontology, so it's much more than just a data model. What are those delegations, sort of financial delegations? Who can approve up to particular limits? Right, what are some of the specific rules that we might have? Hey, if we've got litigation active, then we're actually going to have to escalate and take an alternative path through our approval process. And actually a lot of this stuff is documented, right? And I think this is one of the challenges where we've sort of fooled ourselves and not got stuff out of production because we've just been sort of throwing naive rag at these problems. It's like, okay, we'll just get the SOPs and we'll throw them in a vector store and like you can go and pull the stuff out of a vector store. And again, I think we've done an excellent job of building stuff that seems to work, and then we either put it in production and it doesn't work, Air Canada, or we give it to our risk teams. Who's got a risk team in their organisation? Yes, or lots. Right, give it the risk team and basically computer says no. So this is a way to help to get these things into a state where they're actually going to generalize in production. So I've got a demo. Now the problem actually these days is you build a toy demo and the models are too clever for your toy demo. So there'll be a little bit of that because the toy demo is sort of around the pharmaceutical stuff. And I will tell you right now that Claude is a much better doctor than she is a know your customer under Austrac's KYC requirements analyst. But anyway, let's sort of roll into that. And I'm probably going to need to put my specs on. So I will show a little bit of Microsoft stuff, but it's all open source. So one of the places that I've been doing a lot of work with this is around, we've got a tool set called Fabric, which is basically our big data platform. Fabric users in the room? Sprinkling. Thank you. Thank you. And someone in the Fabric team vibe coded this really nice little ontology playground. It's basically just a cool way to graphically riff and build out RDF ontologies. And so if you want to start to have a little bit of experimentation and playing in this space, like you can just like vibe ontologize in this tool, and that's really what we're going to do a little bit today. So you can go and build some ontology and sort of create those relationships and so forth. So I've got a couple of ontologies here. The first is sort of a pretty simple doctor one, and I picked this because everybody's had to go to the doctor in their life. Not everybody's had to have a mortgage, and not everybody's had to do a full family trust KYC process with their bank. Everybody's been to the doctor and had a prescription, right? So we've got appointments, patients, diagnoses, which is treated by prescriptions. Providers make diagnoses, they prescribe prescriptions. And then we can ultimately build that graphically. So again, it's pretty amenable to be able to sit down and riff out with a business user. And then you can export that as RDFL. And this is ultimately what we're going to provide as effectively one-shot context into our agent. Oh, what's gone wrong here? Uh-oh. Wait one. Let me grab my, like a good television chef, I have the RDF here. I should do. Okay, better. So this is a more extended ontology, right? And so it's still an awfully simple ontology, right? But we get a huge amount of value even from quite a simple ontology. And this is one of the big differences with sort of the semantic stuff of the noughties, is that it was really predicated on, like, while they said, hey, it's an open world model, actually there was no machine capable of having an open mind and working with your open world model that was incomplete. And so the solution to that was like, we'll just get some business users and we'll beat them over the head to build a complete semantic model of our organization. And they're like, why the hell am I doing this? And that's kind of why it fell over. So you can achieve a huge amount with actually quite simple ontologies helping your agents to be able to reason. So now we've got, and it becomes even more significant the more esoteric your domain, right? This is not a particularly esoteric domain. Like, should be unsurprising that the frontier models do a pretty good job of understanding sort of the basic medical domain. They do a really good job, right? But if you have quite esoteric domains in your organization, becomes really important, particularly domains that aren't public. So here, we've actually added some things. So a diagnosis is a diagnosis of a disease. A prescription prescribes a medication. And a medicine is indicated for some diseases and contraindicated for some diseases. So quite important in terms of prescribing safety. And then if we chuck that into friendly Claude, I built a little JSX to go through this, and I will need my spectacles. So we've got sort of two things here. One is we've got an approach without the complete ontology. And the other is where we actually fill out the ontology more. And I'll chuck this JSX up in GitHub so you can have a bit of a play with it as well. It's pretty simple. You just tell Claude to open it and render it as an artifact. So we can pick ourselves a patient who's got a peptic ulcer, so let's not give her an anticoagulant. And we can go and run that. And then without the complete ontology, right, without the ontology, we're going to be able to see how does the AI model deal with it. Now it's going to do a good job still, right, because it has a really good understanding of anticoagulation and disease. But it's not necessarily going to explicitly block it. It's going to be quite verbose in terms of how it explains its reasoning. It's going to provide reasoning that we can't necessarily reason over in a structured way, right? Whereas when we provide an ontology, we can actually ask the agent to reason the problem out with the ontology. And then if we want to, we can double check that. So we can ask the agent to emit back to us its structured reasoning expressed in ontology language and terms, and then we can actually go and use a separate, I won't call it non-AI, but a symbolic reasoner, and I'll show an example shortly of how you can use a reasoner as an MCP server within Claude. We can go and actually ask it to do a separate check on its reasoning to make sure that it's logically consistent with the ontology that we've provided. So obviously it's going to do a pretty good job as a doctor. Claude, she's a good doctor until we start sort of stress testing it a bit and providing things that aren't actually in the training set. So what we've done is we've made a little bit of stuff up here. And so again, what we're looking for is we actually want the agent to reason over the problem and to use our structured data to be able to answer rather than work from its general knowledge. But we do want its general knowledge sort of to help with sort of general medical understanding. And we probably do want its general knowledge to be able to be relied on for things like sort of reasoning particular diseases into the classes that we might have represented in our ontology. So in this case, both have blocked it, but one's blocked it because we actually were able to reason over the structured data, and you can see it's able to provide specific, referenceable, auditable information as to how it came to this conclusion. The other one's just saying, hey, I don't know what this is, but here's 6 paragraphs of AI slop to tell you that I don't know what it is, right? And and again, there are going to be situations where actually you do want to present that to someone, like being able to have both sort of the plain language explainability for people, but also be able to emit a structured representation of what that reasoning was so that we can separately validate that reasoning is really important, right? Because you get into these regulated industries and you can't get away without having really auditable decision-making processes. And then the other thing I thought would be quite interesting to have a little look at, and again I'll share the JSX, but this one's less functional just because it's a little bit slow. So we'll just sort of step through, right? And that is one of the things that's really unlocked by LLMs is their ability to work interactively with us as coding agents. And we can get them to work interactively with us and, given an appropriate user experience with business users, to iteratively build out that ontology. So in this example, once again, we've got sort of a faked up medication that at the moment we go into a Sparkle query over the ontology store and don't get any results back. And the ontology store I'm using, there's a GitHub repo called Open Ontologies, which is a nice little Rust-based MCP server that actually gives you an embedded triple store, a symbolic ontology reasoner, so you can actually ask it to go and like take this ontology and help me understand what new rules are inferred by what's in it already, and given some other data structure, is that logically consistent with the ontology? So we can use this to double check some of the reasoning that comes out of these AI models. They're really good at reading things, turning them into structure. All right? So that ability to go and read, say, the label on a new packet of medication and start to turn that into structure and use that to, under the supervision of a domain expert, but probably improving their productivity by an order of magnitude or two, start to extract that information into maybe language, and then extract that information and actually use it to help us author the structured ontology that we'll then be able to put into our knowledge store. So again, here we can see that our new novel class of drug called a SMAC, villarixine, right, is now able to be represented inside the ontology in our knowledge store. We can use our MCP, I double-clicked, use the MCP server to load the ontology into the ontology store, and then to reason over that. And again, this is not reasoning in the large language model sense of the term. This is reasoning in the symbolic AI sense of the term, which is actually go and reason over sort of these logical relationships, work out any new relationships or rules that are inferred by that, which again is that mechanism by which we can do sort of a second check on the reasoning that might come out of our language models. And then once again, we can go and run that. And you'll see that when we have an actual ontology, we're going to always get a consistent result. But if we don't, I can start flipping models, right? And we're going to start to see inconsistent results and all sorts of things, right? And if you have auditors come in as part of your risk team and things, that's the first thing they're going to start doing. They're going to go, okay, what happens if we change the model version? Oh, system breaks, right? You're not going to prod with that. So yeah, what this does is helps us build much more robust, more generalizable agents in the context of our organizational processes. Right, specs off. Okay, so that was an example, contrived, as you can see. Claude, she's a great doctor. Let's talk a little bit about KYC. Who does KYC in their organisation? A few. Who's heard of tranche 2? Tranche 2. Tranche 2 means that now, as well as your bank doing KYC, your real estate agent does. So these requirements actually now apply to a whole swathe of organisations in this country. It's actually created a real cottage industry for KYC SaaS apps. I worked a bit in a bank, so this is informed a little bit by some of that time working with FSIs, right? So KYC is know your customer. Here in Australia, that's governed by an organisation called AUSTRAC, and we're going to talk a bit about doing KYC around trusts, because it's quite a complex process. Here in Australia, you typically have, or at least AUSTRAC classify you as having 8 distinct trust types, each with different regimes, regulatory requirements, and requirements for verification of various parties and information. You're typically doing that verification across a set of sort of dense, unstructured, to the extent that they're just documents, unstructured documents, trying to sort of pull out information, work out which regulatory regime applies, and all of those sorts of things. You can have, it's really important that we find the appointer of a trust for a discretionary trust, right? But they're called the principal, they might be called the guardian, they might be called the custodian. AUSTRAC doesn't really care what they're called. AUSTRAC cares what they're empowered to do under the various trustees and any amendments to those trustees. So it's quite a complex area, and literally in banks there are hundreds of people working on this all day, every day, like pouring through documents trying to pull this information out. And it really is an escalating regulatory area. Like it's escalated a whole bunch over the past 10 to 15 years. KYC, anti-terrorism, financing rules and so forth. So it's become quite complex. And as I said, there was a thing called AUSTRAC Tranche 2, which is we're in full flight around, which basically means law practices. They tend to be good at reading legal documents, but it's expensive for them. Accounting firms and real estate agencies now have to stand up all of these sorts of KYC processes, and so ultimately have to run this sort of stuff. Most of them have never done it before. Most of them don't have teams of hundreds of people equipped to do it. Most of them probably aren't doing hundreds of them a day like a big bank is, but if your real estate agency still has to do it, and they might do one or two a month, what do you think the quality of that process is actually going to be inside that organisation? AUSTRAC knows exactly what it wants, right? So it wants us to pull out information like the name of the trust, the type of the trust, who was a settler, appoint a guardian, all of the beneficiaries, and there are certain rules around beneficiaries and the beneficial owners of the trust. All of this information tends to be contained in trust deeds. I'll talk to you about an exception shortly, right? But it's not like the trust deeds were written for AUSTRAC and KYC. So what sort of, it's not like it says at the top of the trust, this is this type of trust, right? Often you actually have to reason over the document to see how is that trust operating, to understand what type of trust is it, and therefore what sort of regulatory regime should we place it under. So it really is quite a complex reasoning problem. The good thing though, well, good thing for these organisations, bad thing if you're a fourth year law student at university, is that legal documents are surprisingly structured. So the law profession is following fast along behind all of us in this room, in the software engineering profession, and that legal documents are written in English, not dissimilar to most programming languages, or some sort of human readable language. But they're written in a very structured form with a much more constrained grammar, right? That's one of the reasons that LLMs do so well as coding agents, right, is that we're actually giving them much more constrained language to work with. And the law is nothing if not that. So it's quite amenable to this sort of attack, reasoning over this language, but there's no GitHub for the law, right? And that's a bit of a problem. It's not like, you know, my coding agent can go and trawl through GitHub and millions, billions of lines of open source code. It can learn an enormous amount. We can't do that. And in particular, some of these quite niche processes, and certainly the ones that are private to your organization, not public to your organization, we need to be able to do a better job. And actually the better way to do this is to be able to give this ontological representation to the models in a one-shot, few-shot, rather than try and fine-tune models and so forth. So, trusts in Australia. Who's got a family trust? Handful of people. Handful of people. And go well with rental properties. Who's got a rental prop? No. It's the Australian national sport, isn't it, landlording? Certainly not rugby. So, discretionary trusts, unit trusts. We'll all have an investment probably in a unit trust. Testamentary trusts, we're going to talk about shortly. Hybrids, bit of fixed, bit of discretionary, charitable trusts. Special disability trusts are created by legislation, so actually a lot of the sort of the mechanics that we see around how that trust operates are expressed in legislation. Again, legislation is pretty amenable to reading with a language model. The complexity is real, and it is really complex, and like these KYC analysts, it is a skilled, like intellectually taxing and toilful task to be a KYC analyst, because it's a really important task, and there's awfully big fines if you stuff it up. So it really is something that actually bringing agents to work alongside people and reduce some of that toil is fantastic. So let's focus on a couple. Discretionary trusts, the sort of the common family trust. A few interesting things here, right? So the appointer really holds that ultimate control, because the appointer can appoint trustees and reappoint trustees as they go. So they're a really important person to be able to go actually do a KYC check on. KYC, we ultimately sort of look through the trust, look through all the companies, until we start finding fleshy things. Keep looking until you find human, and then KYC the human, right? So we ultimately have to go and try and find out who is the appointer. The problem is that the lawyers didn't write this for KYC, so the trustee doesn't necessarily call them the appointer, might call them the principal, might call them the guardian. We actually need to go and look at how does the trust operate, and who is the person in the operation of that trust as set out in that trust deed who appears to be exercising these powers. If we can describe the nature of those powers in our ontological model, we can actually then apply that ontology to go and process that document and extract the information we want. Then there's some interesting stuff around beneficiary classes. Hey, my trust, I'm going to talk about future spouses. This is my current wife. This is my, we can talk about future children. And again, like those are great concepts, but we're going to want our agent to be able to sort of understand, like, what might I be able to do to resolve that? Are there other systems that I can go and look at that might be able to give me information about spousal relationships, say a customer database, or do I actually need to shell out to my KYC analyst to help to answer that? And the other really fun and interesting one is a testamentary trust. So that basically is sort of created as a virtual trust when you die. So there's not necessarily any standalone trust deed document in it. You might be able to get some information out of the will. You might be able to pull some information out of other probate documentation. So we actually need our ontology to start to sort of understand and model out sort of the death and sort of wills and estate administration process as well. So this is some research from McKinsey that it takes 2 to 4 hours to onboard a single trust through a KYC process. So that's actually a really onerous process, and it is a really complex process, and literally, like, it's done with people poring over documents, printing documents out, highlighters, spreadsheets. It's really, really manual, and it's really, really toilful. And it's really, really open to this sort of agentic, co-pilot style improvement. The obvious answer, the naive answer is, okay, I'll grab the deeds and docs, chunk them up, stuff on a vector store, slap a chat interface over the top, and wham, bam, thank you, man, we've built a RAG system for the KYC analyst. Knock yourself out. Now you can go and ask questions, whatever questions you want of the document set. And so what do you ask it? Who is the appointer? Right? And what happens? Well, it probably works with your sample data because you've got some nice, carefully picked sample data. And the sample data is basically you've kind of overfit the system you built because you built the system by looking at the sample data that the business provided you. So it works for the sample data. And then you go and put it into prod or actually give it to the risk team and it all falls over. So again, there's a fundamental problem for us as software engineers in that we are building things that we think work and actually they don't. So, here's why it's not enough. It doesn't know what it doesn't know, right? I can build a RAG system, you can go and ask it questions, but it doesn't really have a model of what are those complete set of facts that AUSTRAC wants to know. It doesn't know what should have been asked, what does it need to resolve? But then that deeper issue is that a pointer one, right? Like there are a whole lot of things from experience in these documents that are not labeled, they're not named. You actually have to reason over how does this entity operate through construction from this document, how does it operate? And the way it operates tells me who are the people who fall into some of these categorizations. Like it really is sort of classical reasoning. So it's a lovely sort of worked example to be able to have a crack at. It can't apply those type-specific rules, right? So the obligations really do differ from AUSTRAC across those 8 different trust class types. And once again, like there's nowhere that says this is the type of trust it is. And in some cases, particularly sort of hybrid and discretionary trusts, right? I don't really know. I've actually got to go and read all the documents to work out like how much discretion do the various parties have inside that operating arrangement. And so having this model to be able to reason over helps us reason which regulatory regime is actually going to apply. Again, apply the wrong regime, you don't KYC the right people, don't KYC the people, you've failed from a compliance point of view. And we're reasoning over the actual mechanics expressed in the document. It can't reason over ownership chains. So another really important thing when we go and do this is we often need to traverse those graphs like entity, 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 human. And we're going to traverse that through documents, through other enterprise systems and so forth. So actually you need to have that meta understanding that there's probably an ownership graph that exists to be able to sort of reason over the tools. Okay, I've gone to the document and I've found the beneficiary, but I've also found that there's a future spouses clause. I need to have a meta understanding that future spouses might be able to be retrievable from our customer information system, or I might need to go and actually shell out to my KYC analyst to have that happen. And again, that's not contained in those RAG documents, and it's not contained necessarily inside standard operating procedures. And it produces no audit trail. Well, you can get it to write you some long paragraphs of text. You can get it to sort of tell you which chunks of the document it pulled out. But you can't actually get it to explain to you why did it make that decision. Now again, with a KYC analyst, AUSTRAC tends to be comfortable that you can go and talk to the KYC analyst, right? But if we're going to get machines to start to do this, we need to be able to make sure that those machines can express what was their thinking in terms of how they approach this problem. And again, the nice thing about having an ontological model is you can actually express that thinking in ontological terms, and you can use like structured reasoners, like symbolic reasoners to actually look at the reasoning that was applied and double check some of the things that are being done. And it can't enforce completeness. So it can't enforce completeness, resolve ambiguity, know where its not able to answer questions. And this has actually improved a lot. This has improved significantly in the past sort of 9 months or so. So it's a bit less of a problem these days, and that the models, they've reinforcement learned them to be a whole lot better at actually sort of putting their hand up if they can't do something. But then it's like, what do I do if I can't resolve something from this current information set? How do I reason over the tools that are available to me, both shelling out to human and working with MCP servers and so forth to actually go and access that information? And then your ontology design becomes sort of a well-governed design time concern, because the problem with sort of the initial approach we all took was, we'll slap the SOP into a RAG system, and then to work out how the process works, you can just go and like vector search the process, or we'll just dump the whole SOP into the million token context window, which is, again, expensive, and it's kind of just sort of, it's like vibe coding at runtime. And again, it's risky, but that risk is so often hidden from us. Like, I can't reinforce enough that we've been building a lot of systems that we think work and then they actually don't generalize. That's why everybody was sort of hand up, yep, we've delivered a POC, but it's actually not got anywhere. So turning this into a well-governed design time concern, and then we can build these things up iteratively, supported by tooling that's actually using language models to extract this knowledge graph at design time, rather than sort of swinging for the fences and hoping, right, that we can extract sufficient meaning by one-shot learning, throwing the SOP document into the context window at runtime. So we model Australian trust structures. How do these work? And again, we've got lots of source material we can go and do here. There's lots of good understanding already in the models. We can go and help them read some wills and trusts textbooks. So like, we can build up this information, this ontology, iteratively as a design time concern, in the same way that as software engineers we build this up by coding with the agent. Legal document anatomy, trust deeds, wills, read some trust deeds, extract sort of the way that they operate. The regulatory requirements, actually that's well encoded already in the models. And how does our KYC process work? What organizational information can you get access to? Ontological models of that, and so forth. And then build some agents. Document ingestion agent, this is really the key, this is a key thing, right? So many people miss out the idea that you sort of, that you can go and pull structured information out of these documents. An agent that applies that regulatory logic, and then agent that actually interacts with your KYC analyst. So that's that kind of analyst partner. We are not going to remove, like, we're not going to take people out of this process. There is no straight through processing of this stuff. Right? And it won't get past risk, and you just can't do it. But what you can do is you can take a lot of toil out of the lives of these people who are literally laboring under a swamp of shared inboxes. So it's not just about reading the document, it's about actually reasoning over it. It's about actually understanding how does the entity that's been set up by this trust deed actually operate, so I can understand who do I need to actually go and do the KYC on. The ontology gives us the ability to get that reasoned answer, and it gives us a way to have an auditable record over the top of it. Some tensions and questions. Now, who owns the ontology, right? Like, is it engineering, like the data team? Is it the business? Is it both? Is it neither? I think sort of where we're landing on, certainly from Microsoft, we're starting with this from kind of Power BI backwards. So we're basically saying, okay, the business users who are kind of working in Power BI and Excel, how can we start to capture some of the ontology that they're already thinking about as they work with data, and kind of explicitly model that so it's available for other systems? I think realistically it's probably business driven, but with a level of robust engineering process and governance around it, versioning and all of those sorts of things. Top-down versus emergent ontologies. Do we design it first, model before we build, or do we try and sort of derive it from existing documents, code, schema, and so forth? It's going to depend a little bit on your on your specifics, but both approaches are made so much more tractable by actually having LLM tooling that we can apply to it, particularly sort of the bottom up. The formalism ceiling. So this was always the challenge with the semantic web back in the noughties, is like it really only started to work because we were using symbolic reasoners, right? They all said, like ours open world and it assumes open world, but because we're using some symbolic reasoners, there was no intelligent machine looking at the model and going, like this is an incomplete ontology, but I've got enough knowledge about the world that I can sort of fill in some of the gaps. And what that meant is you actually had to have quite exhaustive, like ontologies, and that's changed, right? So now we have these agents that can fill in a lot of these gaps, so they can do a huge amount even with a relatively simple ontology, and you can build on that iteratively. So it's really amenable to sort of incremental improvement through time. The objection is just a well-typed API, and to a degree that's true, but sort of think of the ontology as being at sort of a couple of levels higher, so able to sort of represent concepts shared across multiple APIs and so forth. Schema evolution is still painful, and yes, like that model evolution is still going to be painful, but actually it's valuable to do because you can sort of get that incremental uplift, and you're not necessarily getting the sorts of breakages you'd get otherwise, because you can actually reason over the mapping of the ontology to the underlying physical system. So again, one of the challenges is always, right, we now have yet another model that we have bound to sort of the underlying physical data model, our logical data model, and now we've got yet another brittle relationship that will break. Well, actually, you don't necessarily have to explicitly map the ontology to the logical data model. Like a whole lot of that can actually happen at runtime. It's really robust to do it at runtime, and it means it's a whole lot less brittle to be able to do that at runtime as well. Ontologies will encode LLM bias, and the answer is yes, but actually, like the way that we solve for bias through approaches such as model alignment, being able to do that model alignment in the context of an ontology is really useful. So if we want to change the way that the model behaves and thinks about certain sort of things, we want to be able to build a model of those things and sort of provide that alignment guidance within the context of that ontology. The vendor interrupt problem, I'm from a vendor, so this is a big one. Everyone's going to have their own ontology. Actually, some of the feedback that we get about ours, it's not open standards and all those sorts of things. Part of the reason for that is kind of we started with GitHub. Sorry, we started with Power BI and sort of working back from there. I suspect that's going to improve. We'll be able to round trip ontologies in and out of Fabric at some point in the next sort of 12 to 18 months, hopefully. This becomes a whole lot more tractable with these language models. So again, some of these things like sort of resolving between two ontologies actually becomes quite a tractable problem if you at least have the ontology. So I suspect what we're going to end up with is sort of a federated model, different vendor technologies having their own ontologies, and a mixture of design time and runtime reconciliation between them. And again, I think we will find it as significantly less brittle than we might initially think. I think the other really important thing to take away is you don't need completeness. And this is sort of the big change from the last time that we were thinking about ontologies, right? And that we really needed to have quite exhaustive models. We actually don't here. Like, you can start really small, and even a very small ontology, particularly for an esoteric domain of domain problem, is going to provide significant uplift in the ability of the agent to reason over the problem. Like, it's like crack for one-shot learning, right? Because you're actually putting that in a structured form into your context, rather than slamming it in an SOP document. So what to do Monday morning? Like, pick something small. Like, pick yourself an idea. If you've built some of this sort of stuff already, if you've got one of those POCs that's not hit production, pick that. Write down what are some of the rules it must honour, and see actually how are those represented and encoded at the moment. And then think inside the box rather than outside the box. Don't try and model your organisation all up. Don't go and build a massive enterprise semantic model platform and so forth from the get-go. Actually start small and use some ontologies as part of a small system, and just look at how it improves the ability for these language model-based systems to be able to reason over and resolve your business problem. And then just incrementally improve from there. Measure for correctness and measure for cost as well, right? So these bigger models are getting much slower and much more expensive. And so that can be a real problem. And so the other thing that ontology gives you is it does mean that you can generally get away with a much smaller model to do your work for you. That's me, folks. Hopefully that was some interesting content. There's definitely some actionable stuff there to take away. And I think for, again, that big load of hands who said we've got stuff that we haven't been able to get to production, this is an approach that does help smooth that path through risk teams and organisations to actually get LLM-driven software applications into prod. With that, thank you very much, and look forward to seeing you later in the day. Are we doing questions? I wasn't sure. I ran up to time. I ran all the way to time because I assumed no questions, but I'm happy to take questions.